Hi, my name is Arun, and in this video I will be talking about multi-dimensional arrays in C++. To understand two-dimensional arrays, think of a one-dimensional array as having only one row with a number of columns that you, the programmer, can choose. Two-dimensional arrays are arrays where you specify both the number of rows and columns. You can visualize a two-dimensional array as a table similar to what you might find in Microsoft Excel. To declare a two-dimensional array, we first specify the element type that will be stored in the array. Then we have to provide a name for the array. Next, we write the number of rows we want to allocate in brackets, followed by the number of columns in a separate bracket. For example, we have an array named ARR that has 2 rows and 3 columns. Since we only declared the array and did not initialize any values, it will contain garbage values which can be different each time the program runs. There are several methods to initialize multi-dimensional arrays in C++. One common approach for initializing a two-dimensional array involves declaring the array and then specifying the elements using nested curly bracelets. Each set of curly bracelets represent a row in the array, allowing you, the programmer, to group the elements of each row together logically. In our example, we have a two-dimensional array of integers named ARR. This array has 2 rows and 3 columns. The first row contains the integers 1, 2, and 3 for each respective column, while the second row contains the integers 4, 5, and 6. To access the elements, we write the array's name, followed by the index of the row in brackets, and the index of the column in another set of brackets. This table provided shows us the indexing of a two-dimensional array with 2 rows and 3 columns, just like the previous example. Remember, indexing always starts from 0. The first row has an index of 0 and the second row has an index of 1, and this also applies to column indexing as well. Let's try accessing the integer 5 in the ARR array. The integer with the value of 5 is located in row number 2 and column number 2. However, since indexing starts from 0, row number 2 has an index of 1 and column number 2 also has an index of 1. Therefore, we type the array's name, ARR, followed by the row index in brackets, which is 1, and then the column index in another set of brackets, which is also 1. If we output this using cout, the program will display the integer 5, which is stored at the specified row and column. Now, let's access the integer with the value of 2. As we can see, the program outputs 2 when we access the row with the index of 0 and the column with the index of 1. Lastly, let's access the integer with the value of 4. It is in the row with the index of 1 and the column with the index of 0. When we access this location, the program outputs 4. To modify a two-dimensional array, we access a specific location in the array and assign it a new value. In the example, we are accessing the integer in the row with the index of 1 and the column with the index of 0. Then we assign a value of 10, changing its value from 4 to 10. If we output the integer at this location again, we will see that it's now 10 instead of 4. Now, let's move to the fun part, three-dimensional arrays. They are much more simpler than most people think. Make sure you understand two-dimensional arrays before diving into three-dimensional arrays. Three-dimensional arrays are essentially several two-dimensional arrays stacked together. To declare a three-dimensional array, we write the array type and name, then specify the number of two-dimensional arrays in brackets. Then we have to write the number of rows in brackets and the number of columns in a separate bracket. Each bracket represents a different dimension. For example, we have an array of integers named ARR that consists of 2 two-dimensional arrays, each having 2 rows and 3 columns. To initialize a three-dimensional array, we declare the array and then use nested curly braces to group each two-dimensional array. Inside those, we again use a nested curly braces to group the elements in each row. Let's look at an example to understand this better. In this example, we have a 3-dimensional integer array. It consists of two 2-dimensional arrays, each having 2 rows and 3 columns. In the first set of curly bracelets, we specify the elements of the first 2-dimensional array, where the first row contains the integers 1, 2, and 3, and the second row contains the integers 4, 5, and 6. The second set of curly bracelets represent the second 2-dimensional array, which consists of the first row containing the integers 7, 8, and 9, and the second row containing the integers 10, 11, and 12. Accessing and modifying elements in a 3-dimensional array is very similar to the process for accessing an element in a 1-dimensional and a 2-dimensional array. We write the array's name followed by the index of the 2-dimensional array, the index of the row, and the index of the column. To change or modify a value, we access the array and assign it the new value we want to assign. Here is a diagram showing the indexing of the 3D array we declared and initialized in the previous slide. I know this can be confusing, so if you have any questions, I will be happy to answer them in the comment section. Also, if you have any suggestions for me, please write them in the comments so I can improve my upcoming videos. Thank you for watching my videos.